Meet my 4-jaw chuck. It's a big 4-jaw chuck. It weighs 28.4 pounds. This is a 3/4 horsepower lathe. To install it, I have to juggle it in one hand while trying to feel around the back of the giant faceplate to find the screws to get it on the first screw. Once it's on the first screw, it's less likely to fall on the floor or break my fingers. But this thing has been annoying me for a very long time. 20 years? 24 years? A long time. It's time for a change. Our friends at Grizzly have sent me a package because I paid them to. None of this stuff is sponsored. As usual, they pack stuff very well, and they have these made in Taiwan boxes. These were on sale, although with the shipping they still ended up costing like 40 bucks each. So the plan here is to replace the existing faceplate, which is like 8-inch, with one of these that's actually made for this particular size of chuck, which is 160 millimeters, which is about 6 1/4 inches. I expected these to be raw castings, but they actually turn out to be machined, which is very nice. And these weigh 12.2 pounds, but they're going to go on a diet. They are very round. Clearance, as they say, is clearance. So starting off, trying to figure out the feeds and speeds for this. My little lathe has trouble turning things that are 6 inches in diameter very quickly, so I'm kind of winding up to the appropriate feed speed and depth. And then we make the register, which is 100 millimeters for fitting onto the existing nose. I made this 5 millimeters deep. It probably should only have been 3 millimeters, but it worked. When I'm centering stuff with the what's it called? It's called a wiggler. When I'm centering stuff with a wiggler that's round, I like to do one axis and then the other axis and then go back and do the first axis again. My feeling is that if I was off center the first time, I would be getting a different effect with it going left or right. I don't know if that's the case. More experienced people could tell me, but that's why I go X and then Y and then X again. Actually Y and then X and then Y again, because this is the Shoptask is all turned around 90 degrees. We come in and we center drill for our 3 mounting holes, which are on a 115 millimeter diameter circle. And we're going to drill and tap these for 10 millimeter by 1.5. I'm not sure why I did this one twice. Something went wrong there. I think I had the feed set too quickly, and I was automatically drilling these, so I had to wind back the feed rate. Sorry about the camera shake. This stuff is messy, so I'm trying to keep the amount of cast iron getting into the machine down to a minimum, but I'm not sure how successful I was. And then tap the holes. Not going to film all that. And then we need to take this down to thickness, because it comes, I think it's like 30 millimeters thick, and I only need it to be about 20, so we have to take off about 1/3 of the whole thing. So a lot of this video is sped up. I have 7 hours of video in the can for this project, and we took it down to 25 minutes, I think. No, 15 minutes, I think I got it down to. The ridges that you could see on the early turns there is because I hadn't locked out the Z-axis, and the CNC was adjusting back and forth. It does an oscillation when it's doing that kind of thing. And I disengaged the CNC on the Z-axis when I'm doing finishing cuts. And I did find On these heavier cuts on the cast iron, I needed to lock it out there too, because when it would wave in, it would cause the tool to jam up and the whole thing would stop. So I think we've got it down to 20 millimeters now. Pretty good surface finish. Clean up the mess. Cutting the register, this is 140 millimeter we need to bring this down to. And here I'm doing it 3 millimeters deep. Again, having issues with the outer diameter cutting too deeply and the machine locking up. It takes many small passes. If you're enjoying this video, please show your appreciation and click the like button and subscribe. And then checking the diameter to make sure the DRO matches reality. And we should be there, so give it a quick deburr. Not that there was much burr, because cast iron doesn't really burr very much. And moment of truth. Nice and snug. Then a quick skim on the outside just to clean up. And a couple of chamfers. Down to 22.2 pounds, so we have lost 6.2 pounds. Pretty good. But that's not the end of this. This is my chuck collection. That's my ER40, my 3-jaw, and my 4-jaw with the new backplate. But the real weight loss here is going to be this guy. A lot of the things I'm working with are model steam engines and stuff, which are very small and don't need a gigantic 4-jaw chuck when I'm doing 4-jaw chuck stuff. So this is an alternative. This is a K72-100. K72 seems to mean 4-jaw in Sanu speak, and 100 is 100 millimeters, which is about 4 inches in real money. So we get this tiny chuck key with a spring, which is going to be removed, and the 4 mounting screws, which look adequate. They seem to be 8 millimeter. I'll verify the thread. Not that I need to, because it's already threaded. I only have to do clearance holes for these. And this is the chuck itself. Again, this stuff all comes very well packed. And this is also quite oily, so give it a wipe down. And this has an 84 millimeter register on it. More turning, more hours of turning. Now we have a 6 and a bit inch, 160 millimeter in fact, slab of cast iron here that we need to take down to 100 millimeters, because there's no reason for this to be bigger than the spindle nose, because the chuck is smaller. So this is a lot of turning, many turns. Many turns. So, I lied, cast iron does burr, but yeah, I can fix that. There it goes. And more of the same. I missed some of the footage here of making the register on the front, but first we have to bring it down to 20 millimeters again. And then the register is another 3mm back from that. Carefully bringing it down to size and final fit. Perfect. Then take some of the extra metal off the outside, just bring some of the remaining metal down to the same outside diameter as the chuck, while keeping the requisite thickness on the backplate itself. Now we're back to the 4-jaw chuck backplate and doing its tapped holes. It actually is 3/8/16 for some Indian reason. It's a metric chuck with imperial mounting screws. I don't know why, but that's what it has. I have a temporary tapping block that I just add holes to as needed to try and keep these things square. And then the mounting holes for the smaller chuck are just clearance holes, but they also need to be countersunk, counterbored, not countersunk. And I don't have a oh dear. Yeah, this has a 12mm drawbar thread, and I have a 3/8 drawbar, so there is no drawbar when I'm using this particular tool. And if I don't put it in enough, it falls out, which is suboptimal. So we drill the hole, but I have to solve the problem of not having a counterbore for the heads. Luckily, I have a CNC mill, so quick G2, I think, with a Z offset, and we can make a counterbore. And I'm going very slow with these, so I'm just going to show you one. But this worked out quite well. This is a 1/4" end mill, and it's just going down to 7mm below the surface there. So the screws will come out 1mm. And there's Mama Chuck and Baby Chuck. And checking for run out. I do have some spindle run out, but there doesn't seem to be any additional run out from the chuck itself. So I do need to look at my bearings and tighten them up. 9.2 pounds. We have lost 2/3 of the weight. And it's also a good idea not to have your x-axis in diameter mode on your mill, because that's a lathe thing. But otherwise it's turned out pretty well. Now I just have to clean up all the mess, as well as the cast iron. I have reverted to messy mode and not put things away. So that'll be a half a day cleaning up, and take that apart, clean it up. And oh, my keyboard.